All right, guys, here we go. This is 2017 free response question number 3. This would be the first of the non-calculator problems on the free response section right here. And what do we have right here? We've been given a graph of f prime. As I've told you guys a lot, probably the first thing you want to do is make a big fat note of the idea that this is not the graph of f, but it's the graph of f prime. That's the kind of mistake that if you made and you failed to notice the difference can get you a 0 out of 9 real quickly on a problem like this. So let's be careful on that. Okay, so they tell us that f is differentiable on this interval from -6 to 5 and satisfies something important, I bet right here, that f of -2 is equal to 7. Again, remember, this is not the graph of f that we're looking at. This is the graph of f prime. So they've given us the graph of f prime, and we've got a semicircle and 3 line segments as shown above. Okay, so in part A, we're supposed to find the values of f of -6 and f of 5. Now again, if they've given you information about f prime, but they want you to come up with information about the value of f itself, this is in all likelihood a fundamental theorem of calc part 1 problem. So what we're probably going to be doing right here is taking a definite integral, and as far as the limits of that definite integral, we want to focus on the one value that we know, which is the value of f of -2, and then focus on the ones that we want to find here. For starters, f of -6. So the first integral I'm going to do here is going to put -6 on the bottom, the lower value, and -2 up there on the top. Now the integrand is going to need to have an antiderivative over here on the right equal to f. So that means that the integrand we want to use right here is going to be f prime, and really the variable you use here does not matter at all. We're not doing fundamental theorem part 2 right now, so I'm going to just go ahead and call that f prime of x, and we're going to do all that with respect to x. Now what they really want to see on this problem is if you're able to make this leap here, that a definite integral of f prime of x would be found by taking an antiderivative of your integrand. And the antiderivative of f prime of x, by definition, is f of x. So we're going to evaluate f at our upper limit, -2, minus the value of f at our lower limit, which is -6. Now there's 3 quantities right here within this equation, everybody. We've got the entire left-hand side and then 2 different quantities over here on the right-hand side. And probably shouldn't be surprising, 2 of those had better be known, otherwise we've got problems. Well, right here, they told us that f of -2 was equal to 7. So this first term on the right-hand side is going to be a 7. We're trying to find the value of f of -6, so I'm not supposed to know that. That means that we better be able to figure out the value on the left-hand side of this expression right here, the definite integral from -2 to 6 of f prime. And of course, that is the graph that we're looking at right here of f prime. So we want the value of the integral that starts right here at -6 and goes until we get to -2. Well, that's not too bad. All we're looking at here is this triangle located above the x-axis with a base of 4 and a height of 2. So 1/2 times 4 times 2 is going to give us an area of that triangle of 4. 2 things to think about. It's above the x-axis, which means it should be positive, and the limits of integration are in the correct order. -6, the lesser value on the bottom, -2, the greater value on the top. So that means that the value of that integral is just going to be 4. And then moving some things around just a little bit right here, we are going to get that f of -6 as we move that to the left and the 4 back to the right, that f of -6 is going to equal 3. So there's the answer to the first part of A. And the second part, I think we're going to do the exact same way. We're going to do an integral here. Now let's see. This time we are looking for the value of f of 5. And we still want to use -2. That now becomes the lower limit of integration, and the 5 goes up on the top of f prime of x dx is going to equal f of 5 minus f of -2. Once more, 3 things here, and we better be able to fill in values for 2 of them. F of 5 is the unknown, so that goes here now, minus the f of -2, which they told us was 7. So that's going to go here. And now on the left side of this equation, we need to know the area, the net-or-signed area between the curve and the x-axis, starting at -2 and ending at 5. So starting at -2 right here and ending at 5, that's what we're looking at. So let's switch a color here. And let's do something different. We are looking at a semicircle, which is below the x-axis, and a triangle located above. So in that spot right there, let's take a look at our semicircle. It's got a radius of 2, so the area of the entire circle would be 4 pi. Half of that is going to be 2 pi. Now it's below the x-axis though, so that is going to be a negative 2 pi for the first part. But then we're going to add to that the net area here above the x-axis, which is a triangle with a base of 3 and a height of 2. So 1/2 times 3 times 2 is going to get us 3 here. Okay, and that should pretty well take care of this then, everybody. We just need to add that 7 back over here to the left, and that should tell us that f of 5 is equal to, I think we're going to get a 10 and a minus 2 pi then for the value of f of 5. Okay, so that is part A. Let's take a look at what's going on in part B. On what intervals is f increasing, and justify your answers. So a few of you guys asked me for some extra help here on problems that were similar to this when we did a mini quiz, I think number 2 last week. So let's talk about how to do that again. Once more, I like to start with the justification first. We want to know when f is increasing. So the statement I'm about to write is universally true in every case, regardless of the problem. A function f increases on any interval where its derivative, f prime, is greater than 0. Again, that statement right there is universally true regardless of which problem we're working on. A function f increases where its derivative is positive, is greater than 0. And since we are looking at the graph of f prime right now, we just need to know where this graph is positive, or above the x-axis. Well, it is above the x-axis right here on an interval from -6 to -2, and then again here on an interval from 2 to 5. So those are the spots where f prime is positive. So what do we need to write here? F increases where f prime is greater than 0, so I think we can now say that this occurs on, here we go everybody, and we were looking for intervals right here from -6 to -2. That was the first part right there. And they always use the word and. Technically, that's incorrect. I really mean to argue with some of these people next time I'm at a conference right here. It should be or, an interval then from 2 to 5 as well. Okay, so that's where we're at right there. And they were looking for an answer and the justification, and we provided both for them right there. So that's it for part B. Let's take a look at C. In this problem, they want to know the absolute minimum value. As soon as you hear the phrase absolute minimum or absolute maximum, we should know what we need to do right here. An absolute min or an absolute max, which is called an extreme value in general, can only occur at either a critical point or an endpoint. Well, we know where our two endpoints are right here at -6 and 5, but we also need to find critical points. So to find a critical point here, in C, we need to take, let's double check, we were looking for a minimum value of f. Okay, so we need to find where the derivative of f, or f prime of x, is equal to 0 or undefined. Now this function is never undefined on this interval right here, but we do know that it does equal 0 a couple of times. Let's see, it equaled 0 right here at -2, again at +2, and then at 5. Now that 5 was one of our endpoints, so we were going to check that one anyway. The ones we're really interested in are x equals -2 and x equals +2. So I'll go ahead and put a plus or minus there as well, and they'll figure out that we knew to check the endpoints from the work that we had here. So if we want to find a minimum value here for this function, we now need to make ourselves a quick little table right here of an x value followed by the value of the function itself. We need to show them that we considered all of the possible candidates right here for where for where an absolute max or min could occur. So our minimum value right here for our left endpoint was going to be -6. Our critical points were at -2 and +2, and then we had 5 for the right endpoint of the entire interval. And I believe we answered some of these values of these questions here back in part A. For example, the value of f of -6 is right here. We already found that f of -6 was equal to 3. And then f of 5, that was the second piece that we came up with right there, of 10 minus 2 pi, Okay, so not too bad. Some of that was given to us as well. All right, so that's where we're at. If we want to come up with f of negative 2, that was a value that they gave us earlier on here. F of negative 2 was equal to 7. So, man, it's our lucky day. 3 of those values were already found for us. What we don't know, though, is the value of f of 2. So I'm going to switch colors over here. Let's go green on this one, and we'll see what we can find to come up with the value of f of 2. Trying to think if there's something easy here that I'm forgetting, and I don't think there is. So I think we're going to have to do another definite integral going from negative 2 to positive 2 of f prime of x with respect to x, and that is going to equal f of 2 minus f of negative 2. Okay, on the right-hand side, we don't know the value of f of 2, but we do know that the value of f of negative 2 is 7. And on the left-hand side, we need the value of this integral right here in between negative 2 and positive 2. So starting at negative 2, ending at positive 2, we're just looking at that region right over there. Again, the area of that entire circle with a radius of 2 would be 4 pi. We just want half of it, so it's 2 pi, and because it's below the x-axis entirely, this is going to be a negative 2 pi over here on the left-hand side. So adding the 7, that's going to tell us that f of 2 is going to be 7 minus 2 pi. Okay, so now, here we go. Back to complete the table now, we've got a 7 minus a 2 pi that's going to be located right here. Now remember, this being a non-calculator question, we got to do a little bit of thinking here. We are looking for an absolute minimum value of the function on this interval right here. So in terms of minimums, we know the answer can't be 7 since the 3 right above it is less than that. 10 minus 2 pi is going to be bigger than 7 minus 2 pi. I think we can see that, so it's not going to be that value. We have to think for a second, though, everybody, roughly, about what the value of 7 minus 2 pi is, and this one isn't too bad. We know that pi is a little bit more than 3, so 2 pi then is a little more than 6, or 6.28 actually, so a 7 minus a 6.28 would get us something in the neighborhood of a 0.72, which I think we can say with some confidence right there is less than this 3 value right here above it. So in terms of the absolute minimum value, I think we found it right here at the 7 minus 2 pi. So let me reread the question in here, and it says, find the absolute minimum value on that interval and justify your answer. Remember that justify does not require a whole verbal explanation. Our work has been our justification. So I just want to say clearly that the absolute minimum value is equal to 7 minus 2 pi. And that is really all that needs to be said or written, and that's our answer there to part C. Okay, and last part here, let's take a look at what's going on in part D. For each of f double prime of negative 5 and f double prime of 3, find the value or explain why it does not exist. So they're asking us to do a little second derivative work, which we haven't talked about at all just yet. So here we go, guys. We are looking at f double prime of negative 5. Okay, so f double prime of negative 5 is the derivative of f prime evaluated at this spot here of negative 5. So boy, I have made a mess of this graph, so let me see if I can't clean this up just a little bit. That was nice. All right, and f double prime of negative 5. Negative 5 is right over here, and if we want f double prime, that's going to be the derivative of f prime, or the slope of the tangent here. So we just need to worry about the slope of this line segment at that particular spot right there. And since it's linear, that's pretty easy to do. We are dealing with a rise of negative 2 and a run of 4 units right there. So our slope is going to be a negative 1/2. All right, so f double prime of negative 5 is going to be equal to a negative 1/2, and I don't think they asked for a justification. I think they just wanted to know what it was. Find the value or explain why it does not exist. There you go, found the value. And the second part to this problem right here is that we are going to find f double prime of 3. I think I have a guess how this is going to work out, but we'll see here. All right, f double prime of 3, yep, that's what I thought. All right, we are dealing with a peak right here where two different parts of the linear function or two different linear parts of the function f prime come together. So what we have right there, guys, in very unofficial language right there, is a corner. And anytime you've got a corner within a graph, very often where a piecewise defined function meets at its seams, you've got a spot of non-differentiability. But explaining everything that's going on right there can be a little bit tricky. So what I would probably say for f double prime of 3 would be something like this. I'd probably say that our left-hand derivative evaluated at x equals -3 would be equal to, and let's take a look at what's going on. If we drew the left-hand tangent ray that looks something like this, we've got a linear function that's going 2 units down and 1 unit to the left. So our slope would be -2 over -1. The left-hand derivative would equal 2. If we considered then the right-hand derivative evaluated here at x equals, sorry guys, just realized that should have been +3. And the same thing right down here, the right-hand derivative at x equals +3. Okay, in this case, our tangent ray is going to look something like that. We are dealing with a slope of, let's see, 2 units down and then 2 units to the right. So our slope is going to be -2 over +2. That is going to equal -1. So what I think we can say with some certainty right here, let me go ahead and get rid of this equal sign. Sorry about that. We can say that f double prime of 3 does not exist, and our reasoning here would be because the left-hand derivative does not equal the right-hand derivative. And I've told you guys a lot during the course of the year, you can't simply say that two things are not equal to each other without actually showing that you know what those values are and that you actually found them. So without this information right over here, if that in red was not present there, this wouldn't be sufficient right here. But because we have it in red, this answer seems to work out okay. Okay, so that is a wrap on problem number 3.